for each of these functions. So, so these are the general forms of some of the stuff that we've worked on, right? Or like the equations, rather, the parent functions, okay? We're going to use them to write a function for each g of x based on its parent function. So for example, this one, the parent function is 1 over x, right? But this has been translated somewhat. I mean, there have been some transformations. We're going to write a function for it, but an accurate and precise function for it. So since this is one of the reciprocal functions, I'm going to use this one, okay? Here, I'm given a point, right? This is the point what? 4, 6. Now, that point is going to be my x and y. Okay? But there are also some transformations here. The transformations are that, look, the horizontal asymptote is now at y equals 4, and the vertical asymptote is at x equals 3. Okay? So my h, right, is -3. Okay? So this is like, or sorry, let's say the h is 3 and the k is 4. So now look at this. So the equation will be y equals a, I'm not going to put in the x and y for a minute, x minus 3 plus 4. Does that make sense with the transformation? Right? Shifted right 3, up 4. But now I also have an x and y. Why don't we plug in the x and y? So now 6 is a over 4 minus 3 plus 4. So 6 equals a plus 4. What's a? 2. So now my function g of x will be 2 over x minus 3 plus 4. Okay? I'll write it here. I mean, we'll have some homework and stuff. Okay, so this one, which one is this going to be? F of x cubed, right? So x and y is what? This is the point 3 and -4. And then for the h and k, you're going to choose this one, right? So this is 5 comma -8. Okay? All right. Because that's the center, right? That's like to shift the cubic one, that's the center. So that's what you have to take. Okay, the center has shifted to that point. Okay, I'll race you to it. How about that? Go. All right, let's do it. So we're going to do y equals a x minus 3, x minus h cubed plus k. Did anybody get anything for a so far? What did you get? -1/2? Oh, it is -1/2. You're right. Okay. So here's what I have. right? So the negative comes from here. When you have x minus h, it's 3 minus 5, which is negative 2 cubed, which is negative 8. Okay? And it should be negative because y equals x cubed looks like this. But do you see how this one goes down on the right? So there is a reflection in the x-axis. Okay, let's do the next one. So what kind of function is this? Square root. What is the h and k? That's here. That's what? Negative 4 and negative 6. Negative a half. So you decide h and k. It's either like, it's basically, you have to see how much transformation has been made, right? So in the case of the square root functions, what do you move first? It's the end point. So that's what you're going to do. For the cubic function, when you're going to graph something with a transformation, what do you move first? You move that center point, 5, negative 8. So that's what we used. Okay? All right. And then the x and y is 0, 2. That's a good one. All right. We'll erase. You guys want to erase? Let's do it. I'll just put it up there, but don't look. Race. Okay, it's a race. Is A4? No. Okay, that's what I got. So x is 0 minus negative h. Yeah. Okay, so this one, this is also a 1 over x, right? So let's see. Let's do the horizontal and the vertical asymptotes. What point do those meet at? Negative 3, 2, right? So if the horizontal and vertical asymptotes meet at negative 3, 2, that's what we're going to use as our h and k. So y equals a over x minus h plus k. Y is 3 over 2 is equal to a over negative 2 plus 3 plus 2. I don't know if I'm doing this right. Am I? So 3 over 2 minus 2, negative a half, is a over 1. Isn't that lovely? So a is a half, negative a half. It's negative. Ask me how I know that. Because in the parent function, right, it's supposed to be like this. The positive is up, but here it's below. So there has been a reflection. Okay? So now y equals, or g of x rather, negative a half, 1 over x minus negative 3. So x plus 3 plus 2. Okay? And you can write that as g of x is equal to negative 1 over 2x plus 3 plus 2. This is how I want it. And if you wanted it to be 2x plus 6, that's fine. Okay? Okay. And then I wanted to throw some of these in there because I know you all love these types of questions, right? Yes. So if f of x is an even function, then f of x is the absolute value of f of x, Is this always, sometimes, or never true? Let's choose our favorite even function. What do you want to choose? X squared. So we say let f of x equals x squared. Now, what is the absolute value of f of x? That's absolute value of x squared. Are they going to be the same? Yeah. But always? Yeah? Okay. What if it was x squared minus 5? Will the absolute value of the function be the same? Let's see why. Why not? Don't just say why. You have to justify it. Because look, will the absolute value of this be the same? No. Right? The absolute value, what would it, this is f of x. What would the absolute value of this look like? It would be like this. Right? Because everything that's negative becomes positive. So, sometimes. Yeah. Huh? Well, yeah, because it says sometimes, always, or never. If x is an odd function, then f of negative x is negative f of x in absolute value. Well, okay, so let f of x equal x cubed. Then f of negative x is not the absolute value of any, right? It's not, right? So if this is f of x cubed, okay? Okay. But remember, it's order of operations. You start from inside and you go up. What's the absolute value of that function? It would be like this, right? And then the negative of it would be a reflection downward. So that's definitely not the same. Well, then, is there never a function? Huh? This is never. Okay? So an odd function is symmetric around the origin. Absolute value of f of x can never be that. Think about that. This is your homework when you go home tonight, is to think about why that is. Okay, if f of x is an even function, then f of negative x is negative absolute value of f of x. Well, x cubed is not an even function. X squared. Okay, so let's say f of x equals x squared. Right? What does that look like? This. Okay, what's f of negative x? No, f of negative x. It's the same thing. F of negative x is the same thing as this. Is that the same as the negative of the absolute value of this? No. But can there be any function? How about if f of x was negative x squared? Okay, what's f of negative x? F of negative x? Okay, hang on. What's f of negative x of this function? It's the same thing. F of negative x is the same thing. Make negative x here. F of negative x will be the same thing. right? Look, f of negative x will be negative x squared, negative x squared. Okay? Does that make sense? Okay, now, so now, what's f of x if, what's absolute value of f of x? Everything's positive. What's the negative of this? Negative, oh look, that is equal to, right? So this one is sometimes. Okay, I'm going to come back to this one tomorrow, okay? Think about this when you go home though. And then Friday, no, tomorrow, I don't even know. Tomorrow, I'm going to come back to this one. Okay, let's do this last one. The figure shows the graph of y equals g of x, which has a minimum located at 1, negative 2. What is the, oh, this should be, oh, maximum value. Yes, what is the maximum value of this? Why is this a minimum and that's a maximum? Because it's being multiplied by a negative, so it's a reflection. Okay? So this is the same as similar to what you had on the homework. So what is this operation doing? G of x, is that the same as the x or the y coordinate? The y coordinate. G of x is the y coordinate. So this is saying negative 3 times the y coordinate minus 1. So in here, that's going to be negative 3 times negative 2 minus 1, 5. B. Okay? Huh? Because that's what the operation is. You're taking all the y values, you're multiplying it by negative 3. Okay? Yeah. Okay. So,